Hello everyone, my name is Muhammad Ali and today I'm going to present this tutorial on how to use malaria edge detection project. Um, this project is officially a part of Project Showcase and this project is going to be submitted in the Project Showcase Challenge of Udacity Intel Edge AI Scholarship. So let's start the tutorial. Um, so I hope that you all can clearly watch my screen. Okay, so first of all, um, we are going to jump into the GitHub repo of Malaria Edge Detection project. I'll share this link of the project in the description. So this is the official repository of Malaria Edge Detection project. And as you can see that there is only one notebook, but um, I have really worked hard with my team to make sure that this one notebook gives you the complete solution. So I believe that making things simple is very difficult because in order to make things simple, you have to reduce the redundancies. And we have tried our best to make it as compact and as simple as possible. So it's my approach that before jumping into any project, I first try to read the documentation, the README file thoroughly, because I believe that many of the queries related to the project is answered in the documentation. So it is always preferable to go and read README first. Okay, so first of all, malaria edge detection with OpenVINO Toolkit. This is the answer of what this project is. And this project is going to use the dataset available at this link. Okay, and what this dataset contains, it is actually a repository of segmented cells from the thin blood smear slide images. Basically, in simple words, these are the blood films from the malaria screener research activity. So this dataset contains blood sample films in which there are blood samples of patients. Now these samples contains parasitized patients as well as uninfected persons blood samples. We will look into it soon. So the next thing is why this project, and what this mean is that why we should consider this project worth spending time on and worth taking part in. So uh, in every 2 minutes, a child dies of malaria. So how um, that's how uh, and that's how difficult and life-threatening this disease is. So there is also a link to this statement, and as well as World Health Organization's WHO data also confirms that globally an estimated 3.4 billion people living in 92 countries are at the risk of being infected with malaria. And just in 2017, there were 219 million cases of malaria registered, and there were unfortunately 435,000 malaria deaths. So these were the deaths caused by malaria. But the good thing is that early diagnostics and treatment of malaria can save lives and prevent casualties. And this is actually the reason that I, along with my team, decided to work on this project so that we can make a malaria detection and diagnosis uh, AI-based model which gives fast, easy, and effective solution using Intel's OpenVINO based Edge AI model and OpenVINO toolkit in short. So afterwards, let's jump to how to use this project. So step number one is open the notebook.ipynb which is available in this repository. Okay, if you scroll up, you will see that there is a notebook.ipynb file. Let's open it in a new tab. So here is this notebook.ipynb file. You guys can clearly see it. Okay, and let's come back to the reading. Okay, so now the second step is click on this button. Okay, so this kind of button will be showing at this notebook. Yes, there is this open in Colab button. So we have to click on it. Okay, let's read the third step. The third step is hover to the menu bar, click on File button, and then click on Save a copy in Drive. Okay, so this is the third step. So in simple words, we have to first go to this menu bar and then click on this File button. Let me zoom a little bit. So click on this File button and then we have to click here, Save a copy in Drive. What this action will do, this will save a copy in our Google Drive. This account will be used for saving this copy. So in my this account, uh, the Google Drive belonging to this account, there this notebook's copy will get saved. Okay, so click here. It says that it is creating a copy. Let's read the fourth step. Okay, so the fourth step is run the first cell that is mounting the drive. Okay, so first we have to run this first cell. Uh, I hope that you can see the arrow here. Click here and then run this cell. You guys can clearly see, I hope that you guys can clearly see there is a play button. You have to click on it. It's saying that it's connecting. Wait for 1 to 2 seconds more. Yeah, so there's a link. We have to click on it. When we will click on the link, uh, a new page will render in a new tab. So this is my Google account and I have to click on it. After clicking, it will ask me that these are some of the data privacy files which I will highly recommend all of you to read. Um, the Google Drive is asking me permissions regarding these files. So I will say allow. I will click on the allow button. And here is our key. We have to copy the whole key, and how we can do this? There's this button of copying. Let me zoom a little bit. There's this button of copying. So we have to click here, click on this button. What this button will do, this will automatically copy whole of the key. Afterwards, we have to come back to our notebook and there in this prompt we have to paste by using Control and V. So when you press Control V, it will paste the key in this prompt and then just press enter. So after pressing enter, it will take around 1 to 2 more seconds to load up. And yes, our drive is now mounted. Afterwards, what we have to do, we have to just click on the model work cell, and it's better to read the fifth step. Okay. So the fifth step is over to the menu bar. Okay. Click on runtime. Okay. And then run after. Okay. So what this is telling us that we have to um, come to our notebook, and then we have to click here in this menu bar. We have to click here on runtime, and then we have to click here on run after. When we will click here on run after, then um, express it. Okay, so what it's doing, it's automatically running all of these cells. Since my purpose is not to rerun this whole notebook at this moment, therefore I am interrupting the cell, but I will suggest you to keep this running so that in a very short period of time, you will see by coming at the last, you will see that your inference will be made. Let me show the inference here. Okay, so it is going to take around 10 to 15 minutes to train the model and then create the ONX conversion model and then the inference. So let's keep it short. So here in our GitHub repo, there is a notebook.ipynb file which we opened earlier, and when you will come down to the very bottom, you will see that there will be a final inferences heading, and you will see that final inferences will render here. So these are the inferences. What the inference is doing, let's keep it a little short. What this code is saying that there's an info.py file. Okay, this is our model underscore fast.ai.xml. Okay, uh, these are blood classes, which are our target labels. The classes are uh, parasitized, which means that yes, this person's blood has symptoms of malaria, and the second class is uninfected, which simply means that the person that is not a patient of malaria. Okay, and there, and then this image path, and this zero means index zero image. So the first image, second image, third image, and fourth image. And these are the, and this NT means top results. So these are our top results, and you can see this accuracy. The first image is classified and detected as with the probability of 9.988 accuracy. So it's 98.87% accurate. The second image is 99.96% accurate. The third image is 99.54% accurate, and the last image is 84.37% accurate. So it's a good model with very good accuracy. And finally, let's keep it a little short. That finally, what will be the flow? So actually, the flow will be that for inference, there will be some input images. Okay, then we will run each cell in the notebook, I have shown you the easy way of using runtime and then run after. And after the whole notebook gets run, um, and after the process will get completed, and then the output will render. The output will render in this form. The output will render in this form. These are the four inferences based on our four images. Okay, and the best part of this project is that this whole notebook contains everything, every single thing that you are going to need for deploying malaria edge detection model. It's it's an edge AI based model, and in this model, um, we have worked very hard to keep it as simple and as elegant as possible. So there's this um, fast AI installation. Fast AI is a PyTorch based um, library to use AI, especially computer vision models. So this is fast AI installation, and this is our data downloading, as well as these are some organization of data into the relevant folder. You don't have to create anything. It will do all the work automatically, and all the folders will get completed on their own. And then its data processing tab. This is our model, and this is our training of our model. Uh, 4 means 4 epochs in simple words here. So in 4 epochs, 0, 1, 2, 3, these 4 epochs has occurred, and this is, and after the training of a model, we have converted our first year model into ONNX as OpenVINO supports ONNX models. And after converting into ONNX models, um, we have created a file with the name of blur.classes, which will simply include classes of our data. And then we have normalized our data, and then there's some data visualization. So these are the images of our data. As you can see that these are clear images, there's no spot there, so that's why these are uninfected images, and this can be verified by this uninfected directory too. Okay, and then we have applied inferences on the images, and since it's fast AI based inference, and fast AI also includes its very own inference engine. So these are the inferences based on fast AI. But since we wanted to deploy OpenVINO based edge applications, that's why now we are moving towards OpenVINO 2. So uh, in in these two lines, we have installed whole of the OpenVINO without of even downloading OpenVINO from the Intel website. And thanks to this OpenDev library project, I have also shared link here. So if you are interested in understanding what this project is about and how this project is helping uh, so many scholars of Intel Edge AI scholarship who are working in their projects to deploy OpenVINO. So just click here and you can easily understand what this whole project is doing and how this whole project is helping other people. And afterwards, we have created our intermediate representation. And after IR creation, we have created our very own info.py file here. This whole code is uh, this whole code belongs to info.py. And the good thing is these whole required files will get created on their own. You don't have to write any single code, any single line of code. Every work has been facilitated by us. So I hope that you guys will like this effort. And simpler. We have only uh, uh, given you guys just one notebook, and this one notebook is a complete package in its very own. Okay, and there are final inferences here. So these are the final inferences. Okay, and these are our final results. So I hope that you guys may like this project and consider it worth working on, because I hope that this whole effort will definitely help people in detecting malaria um, easily and as quickly as possible, so that many of the lives can get saved. And how you can get files belonging to this project. You just have to come to your notebook, and there's this folder called files. When you will click there, it's not showing right now anything because it's not mounted. I'm just telling you as an example, and all of the folders and files will render here. Okay, so that was it. If you guys need anything else, you guys need if you guys need assistance in anything, please you can contact me on Slack. My Slack ID is Muhammad.Ali. Let me show it. Okay, it's Muhammad.Ali. Okay, so this is my Slack ID. You can just search it on Slacks on the Intel Edge AI Slack community, and you can easily find me. And just direct message me, or you can use Tech Help channel to reach out to me, and I'll be glad to help you out in any way and every way possible. So thank you very much. I hope you get positive and constructive feedback from you. Have a nice day, or have a nice night based on your time zone. So, thank you. And I am now signing off. So, take care. Goodbye.